as you look at this graph, notice what's what here. First of all, the blue graph is f of x equals the absolute value of x. Remember, we call that the parent function. It's the parent function because it's always what we're doing something else to. It's the starting function. Now, g of x, the one in red there, that's the one that we're trying to find the equation of. So g of x, notice it's been moved over compared to the original. What can I do to the equation here to cause it to actually move specifically to the right that far? Yeah, so in order to move it over to the right 5, we have to put a minus 5 inside the absolute value with the x. So it's going to be the absolute value of x minus 5. Yes, it has to be inside the absolute value bars for it to do that. All right, now knowing that, a couple follow-up questions, just to kind of look at a little vocabulary here. Where is the vertex of g of x? And so our vertex here, yes, is at 5, 0. Because we go over 5 and up 0 to get to that vertex. The vertex on an absolute value graph, it's where the corner is. But if you wanted to generalize it to any equation, vertex just means that high or low point on the graph. All right, now next up, where is the axis of symmetry of g of x? It's again a little bit of vocabulary. Now to visualize the axis of symmetry, it's actually the line that basically the graph is symmetrical about. So notice here, the axis of symmetry is going right through the vertex. So the axis of symmetry is the equation of that line. Now how do you write the equation of a vertical line? We know it's going to be something equals 5. But what equals 5? Is it x equals 5 or y equals 5? Now most people end up confused about whether it's x equals or y equals. There's a couple different ways you can check. One is, look at our vertex up here. It goes through the vertex, right? What equals 5 there? Is that the x coordinate or the y coordinate?
X.
It is the x. A vertical line has an equation of x equals 5. That's because any point that we might choose on this line, the x coordinate is 5. It's only the y coordinate that's changing wherever we are on that line. Now, why do people get it mixed up? Because it looks like it's the y-axis, right? It's going the same direction as the y-axis. But that doesn't mean it's y equals. In fact, it does have to be x equals. All right, next up. Please write the equation for this graph. So we know it's going to be the absolute value of x minus 3. That's correct. But when we say it, that can mean two different things. We're going to have an x minus 3. The question is, should the minus 3 be inside the absolute value bars?
No.
Or should it be outside?
Outside.
Outside, yes. Because if it was inside, it would move it over. And so, anytime you have that number hanging on the end, that's moving it up and down. All right, next up. What would be the equation of g of x in this case? Yep, this one is actually just like one you did in the investigation. This is 2 times the absolute value of x. Now, why is it 2? Because normally, notice my graph is going over 1, up 1, over 1, up 1. Okay? In this case, it's going over 1, up 2, over 1, up 2. It's going up twice as far as it normally would go. Another way to describe that is saying, well, this one went up 3. This one's going up 6. It's going up twice as far. Remember, we described that as a vertical stretch by a factor of 2. All right, same question for this one. What's this graph's equation? Yep, this one, the equation is 0.5 times the absolute value of x. And a side note here, in the investigation that you did, it was given to you as 0.5. You could also write it as 1/2 absolute value of x, and of course it means the same thing, but it's also fine to use it as a fraction. Now again, how could we see that? Well, again, we could see, okay, when I go over, how far up do I go? So like over right here, I go over 1, and I go up 1/2, and over 1 and up 1/2. And that's how we're getting that. Another way you could think about it is actually the same as slope. Now that works with absolute value. It won't necessarily work with some of them later, but it is the same idea as with slope. Like if I go between any 2 points, rise over run, right? This one goes up 1 and it goes over 2, so it has a slope of 1/2 instead of 1. All right, one more graph here. What is the equation of this g of x? Yeah, this one is the negative absolute value of x, and yes, the negative has to be outside of the absolute value in order for it to flip it upside down. So the negative is put out front in order for it to actually flip across the x-axis like this. It's always a good idea to be writing down the original problem. The original problems in this case, they were a little bit wordy in a few ways. You could certainly write it down, shorten it to something that looks like this as you write it on your paper. But again, having the question to go with the answer is essential for your notes to be useful as a study aid or a help for you later. All right, so for this first one, we're taking the absolute value equation. So I know I'm going to have an absolute value of x in there. I'm translating it up 2, and I'm reflecting it across the x-axis. What do I do to move something up 2? Plus 2. Now, does that plus 2 go inside of the absolute value?
No.
No, it doesn't. Up and down is always happening at the end. And then a reflection across the x-axis. Remember, that is flipping it upside down. That's the one where we put the negative in front of the absolute value. And yes, we could include the y equals or the f of x equals there. All right. Next up, we're translating right 5 and vertically stretching by a factor of 3. So again, I start with my absolute value of x. In order to move right 5, what am I going to be putting in there? Is that a plus or a minus 5? It is minus 5. That oftentimes is one of the trickiest things to remember, though, is that when we go left and right, minus actually goes right, plus goes left. It's kind of counterintuitive. But it only is for the stuff that happens going left and right. All right. Now, that minus 5, does it go inside the absolute value? Or does it go outside? Well, if it's going to go left and right, it goes inside. Yep. And so it's going to be the absolute value of x minus 5. Like that. Now, how do we remember that? How do we know which way goes where? You notice that when it's inside with x, it moves it in the x direction, that is left to right. When it's not in with x, it moves it up and down. So if it's in with x, it moves along x. If it's not, then it goes up and down. All right, now there is one other piece here. We got to translate right and vertically stretch it by a factor of 3. That vertically stretching by the factor of 3 means multiply it by 3. That just goes out front there. So we got y equals 3 times the absolute value, x minus 5. Now a little side note here, because it usually comes up somewhere along the line. Do I need to distribute into 3? No. And there's a couple different reasons. One, if we distribute into 3, then this would no longer be a 5, it'd be a 15, and it'd be harder to tell that it's actually moving it right 5. We'd be thinking it was moving it 15 instead. So it's actually cleaner and more useful in this form. The other thing is that when you distribute into absolute value, there's some special rules that we'd have to adhere to and have to look out for. And we just don't want to have to mess around with that right now. All right, now on to our last one. Again, we start with the absolute value of x, but there's a lot of stuff going on here. So let's actually just build it in terms of what goes where. So I need to have something else inside with the x. That's always the shift along x. In other words, the movement left or right. So back here I see, oh, it's been shifted left 10. So in order to move it left 10, that means the 10 goes inside. But left, is that going to be plus 10 or minus 10? Plus, absolutely. So I got the absolute value of x plus 10 there. Great. Next up, let's go ahead and worry about any movements up or down. So it shifted down 7. Is that a plus 7 or a minus 7? Down 7 would be minus 7. only the ones that go left and right are kind of counterintuitive, where minus goes right, plus goes left. Up and down happens the way you think it should. So minus going into the negatives, that's down. Up would be plus. All right, and finally, the one thing I haven't accounted for yet, it is vertically compressed by a factor of 1/4. Notice when I'm making it bigger, I say it's stretched. When I'm making it smaller, I say it's compressed. But they mean the same transformation. They're both describing this thing being multiplied by something. And since it's multiplying, I multiply out front by the 1/4. So, there is our final answer.